If there is no oil inside the engine, just run it at full load for 20 seconds, can destroy an engine. Because when the engine is running, the various components inside will generate high-frequency friction. Without the lubrication of oil, the friction contact surfaces of the will quickly wear and deform.
Therefore, the engine has a lubrication system,
which is our engine oil. The function of oil
is to cover the surface of the engine's internal parts,
to form an oil film,
to avoid the phenomenon of iron rubbing against iron,
to reduce the wear and tear of the engine. The wear and tear caused. Today, we will use three-dimensional to explain
the structure and principle of the oil system.
Boss, please give a like. Let's start to explain it. When the car is turned off, the oil will be affected by gravity.
It will flow back to the oil pan under the engine. So when we just start the car,
there is a term called cold start, because when the car starts,
the surface of the internal parts has no oil.
It's called iron film. When the engine starts, the crankshaft will drive the oil pump. To start working, the oil pump will pump the oil from the oil pan,
pump it up and pressurize it to the engine. But before the oil enters the engine,
it still needs to go through two steps. One is a pressure relief, aiming to ensure the hydraulic pressure will not be too high at any speed.
The other is the oil filter.
Its function is to
filter out metal debris and impurities in the oil, ensuring the cleanliness of the oil entering the engine.
After going through these two steps, after entering the engine, will split into two. One goes to the crankcase in the lower part of the engine. The other part
will enter the valve chamber in the upper part of the engine. Let's talk about the way to the crankcase first.
The crankshaft. There are oil grooves.
There are oil grooves and oil holes for oil supply.
The oil passes through these will reach the inside of every moving part,
covering the surface of each component with an oil film, including the main journal, connecting rod journal,
piston pin, connecting rod, etc.
Since the crankshaft is completely soaked in oil,
when the piston moves,
the oil will be thrown by the rocker arm to the crankcase,
which of course includes the cylinder walls. To prevent oil from entering the combustion chamber, there will be oil rings on the piston. Every time the piston moves down,
it scrapes the oil off the cylinder wall. If the oil ring on the piston is not sealed tightly, it will cause the cylinder wall to be not clean.
Also,
high-pressure gas containing a lot of oil in the crankcase will also enter the combustion chamber through the seal,
resulting in oil burning.
This is one of the common oil burning faults,
and this kind of failure is the most likely. 70% of oil burning is caused by this fault.
The other way, the oil entering the valve chamber,
also has oil grooves for the oil to
holes into the camshaft bearings through the passage,
and then cover the camshaft rocker arm,
intake and exhaust valves and other moving parts, and finally flows back to the oil pan through the timing chain,
and lubricates the timing chain as well. Once we start the engine, the oil is in the oil pan,
circulate and flow between the oil pan and the valve. The whole cycle only takes about 6 to 15 seconds, so about 10 seconds after the car starts, the oil has already covered most of the parts.
But this is only a preliminary. The oil film is still thin. The surface of the parts is not fully lubricated. It usually takes 1 or 2 minutes. The oil can fully cover, and a thick oil film.
This is actually the process of warming up the car. Of course, warming up the car doesn't just mean,
but also the heating of oil, because
the viscosity of the oil changes at different temperatures,
only within the optimal working temperature. The viscosity and fluidity of the oil are optimal. Can it provide the most effective lubrication?
Because there is a gasoline combustion chamber.
So after the oil runs for a long time,
there will be a lot of unburned gasoline substances,
which is carbon deposit and metal parts,
metal debris that falls off due to friction and collision.
The oil will become black and sticky,
which will reduce the lubricating effect of oil.
Therefore, engine oil needs to be changed regularly. When changing the oil, different types and viscosities of oil will bring completely different lubrication effects. Too thin oil. The oil film formed between engine. The oil film formed will be thin.
The engine will wear more during normal driving.
Too thick oil. In the early stage of engine start,
the oil cannot quickly reach each part,
which will aggravate startup wear.
So, both too thin and too thick engine oils are not suitable.
Moreover,
motor oil is also divided into low-temperature viscosity
and the type of base oil.
In the next episode, we will focus on the oil type
and types of base oils. Boss, remember to follow me so you can watch the next video.